Hi guys, let's take a look at this question where we have two charged spheres x and y that are placed in a vacuum at a distance of 0.0 meters apart. Alright, they want us to draw the resulting electric field pattern between the two charges. Alright, so I'll just draw it on the side. So we have a positive charge and then we have a negative charge. Okay, so this is how your lines should look like. They should not touch. It should be a curve going like that, and we can make one at the top like that, and then don't remember the two going outwards. Okay, so it will go from positive to negative. The negatives will go inward and the positives will go outward, and that is how your pattern should look like. None of my lines are touching. I have a little of a curve and I have my directions correct. Okay, 8.2. Calculate the force sphere X experiences due to the charge on sphere Y. So we use our formula F equals to K times Q1, Q2 over R2. K is a constant of 9 times 10 to the power of 9. Our first charge is positive times 10 to the power of negative 6. How do we know it's negative 6? Because of that little weird coefficient sign almost. Then our other charge is negative 5 times 10 to the power of negative 6. And we take that over the distance of 0.04 meters squared. You jot that into your calculator and you get 140,63 newtons. To the right, you'll get up to the right. Okay, you can fact check that. Actually, take out your calculator and check if I got that correctly. Okay, 8.3.1. If sphere Y is at a fixed position and sphere X is free to move, will the acceleration experienced by sphere X towards sphere Y be constant? Yes or no? That answer is no. Explain your answer by referring to the electric field and force. Okay, so what is the answer? So the answer is no, because the electric field is stronger closest to the charges and therefore not constant, which means the force will not be constant, which means the force acceleration will not be constant. 8.4. We have a third sphere that is now added to our little equation with a charge of -4 coulomb, and it's placed at a right angle to X at a distance of 0.3 meters from the sphere X. So there's a nice graph there. Okay. Calculate the magnitude of the net force on sphere X due to Y and Z. All right. So first we are going to calculate. So what we have right now, we have the force that X experiences because of Y. So we have this force here, X on Y. It's right there. We have to calculate Fz on X. Right. So we're going to calculate this equation on this side. So we're going to do the same thing we've just done. That's the constant. Q1 is -4 times 10 to the power of -6 because of the little upside down U there, or flipped U. And then we have 5 times 10 to the power of -6. And then our distance between Z and X, because this is Z on X, it's 0.03 squared. Try that in the calculator and you get 200 newtons. You can write upwards if you want. Okay. Then, that's not the end of the question. They want the net force. All right. So what do we do now? They want F net. So we're going to take Fy on X squared plus Fz on Y, Fy squared. Okay. So we have this one. Fy on Z is 140 times 63 plus the one we've just calculated, which is 200 squared. We get the square root of that answer, and F net is going to be F net squared, we get the square root of the answer, and F net squared is 244,49 newtons. Why do we use Pythagoras? Because this is a right angled triangle. So to get F net, we have to use the Pythagoras method. Okay. And that's it, guys. See ya.